Now let's consider an example dealing with work, calculating work, but on a surface that's not level, on an inclined surface. So you're loading a moving truck. You apply a force of 300 newtons parallel to the ramp to move a 34 kilogram couch 2.5 meters up the 8-degree incline. So we want to calculate the work done by two specific forces. First thing we're going to need is a free body diagram. So I'm going to draw, there's our ramp and the couch on the ramp. Now the forces that are acting, the applied force 300 newtons parallel to the incline. We also have a force of the weight acting vertically downward, the normal force, the force of support, and then a frictional force. We don't want to calculate the work done by all the forces, just by two specific forces. So the first force we want to calculate the work done by is the applied force. Work is equal to F times D. Remember that force and that displacement must be in the same direction. So then just noting the direction of the displacement, the couch is going to move up the incline. So then the 300 newtons and the 2.5 meters are already in the same direction. So there isn't any trig or anything we have to do. This turns to a simple multiplication. 300 newtons multiplied by 2.5 meters, and that's going to give us a work of 750 joules. Part B, calculate the work done by the weight. Well, looking at the direction of the weight, vertically downward, and the 2.5 meters, they're not in the same direction. So then what we need is the component, the piece of the weight that is in the same direction. So we're going to do a little bit of trig. If we resolve that weight into components, y component and the x component, the y component is completely perpendicular, so it's not going to do any work. However, the x component is parallel. It is along the same direction. So let's calculate the x component. Our incline angle was 8 degrees. So then I can use a sine to be able to find the x component, remembering that weight is mass times gravity. So then sine of 8 degrees would be FGX over the weight, mass times gravity, which is 34 kilograms, multiplied by 9.8 meters per second squared. So that's going to give us an x component when we do the calculation of 46.37 newtons. So then when we calculate the work done by the weight, F times D, again in the same direction, the force that we need that's in the same direction is the 46.37 newtons. The displacement, 2.5 meters. Now, 2.5 meters is up the incline. The x component is down the incline. So that means we're going to have a negative sign there. And when we calculate it out, that becomes negative 115.93 joules of work done by the weight force. So then, free body diagram, pretty much necessary when you're calculating work. And then check your directions, make sure you're in the same direction. Force times displacement. Ponder physics.